There you go. So we're recorded and I can introduce you. There's not really much of an introduction for the two of you, but so thank you for everybody for coming and joining the Instant Theme 1 seminar series. Yeah, I'm really pleased to introduce Flo and Laura, who are going to give this presentation as a combo. So shall I let you guys share your screen? Whoever is going first.
So Laura will share the slides for both of us, actually. So
okay. So I'm looking forward to hearing all about your exciting fieldwork. So I will mute myself and hand over to you.
Do you see the screen?
Yep, we can.
Yep.
Okay. So I mute myself.
Okay. So with this talk, I mean, it's not a strictly scientific talk. I mean, we wanted to share a bit what we have been through our last Antarctic campaign, actually, because we have been in the Ross Sea, okay, because this is the Italian sectors, and we had a few projects, but not our project. But mostly what Laura will describe to you is what we have been doing on the George Fiveland margin, which is offshore Waikas Basin, where there's the Cook glaciers and Mertz glacier. So we have been in this area mainly. That has been a bit challenging because we have been at the end of the summer season, so late February to late March, and so we definitely enter in the fall season. So as a consequence, the weather was also kind of looked like fall weather, so very variable. And so it has been tough for some moments. So we have been through a lot of storms and things, but we also testified a lot of climatic processes that we wouldn't have seen if we would have been in plain summer season. So, I mean, this campaign is also very nice for the eyes, and it was also nice for the scientists. But so this is what we wanted to share with you. So Laura, you can move on. Okay, so our timeline was this one. We arrived from Italy, New Zealand on the 4th of February, and because at that moment New Zealand was still on the strict quarantine procedure for the COVID, we had to stay in quarantine in an hotel, actually in 2 hotels, because Italians were really keen on adding on top of the New Zealand quarantine another week of quarantine. So we arrived on the 4th of February, and we left Christchurch on the Laura Bassi, our icebreaker, on the 20th of February. So it has been quite a long time in isolation before leaving. But as you all know, when you plan field trip, you are definitely busy. So we didn't have the time to annoy ourselves in the room, though we were isolated. So we left on the 24th of February, and our first target was the Ross Sea. So we arrived there after a week of navigation. Then we did a few operative signs there that we would not very much describe here because they were not our scientific project. Then we after this first working part of the cruise, we moved to the George Fiveland margin on the 5th of March, where we started to really collect data for Laura's project, actually, and up to the 19th of March, and then we went back to New Zealand and back to Italy at the very end of March. You can. Okay. Vai, metti tutti I numeri. So, I mean, just a few numbers. So on the map, you see, I mean, the track that the ship has been following. So first we went on the Ross Sea, and then left for George Fiveland, and then back to Christchurch. The navigation time was 34 days. So it has been a month of navigation. We definitely had a very long trip, actually. So it was like it was about 13,000 kilometers, so it was long traveling. we saw a lot of mammals actually, and most of them in Laura's area, which was kind of challenging for collecting the data actually, because our campaign was a geophysical campaign. So, well, then Laura will explain to you what are the implications of mammal presence during a geophysical campaign. Now, of course, because we were at the end of the summer season, we encountered very variable weather forecast and extreme climatic conditions. I mean, not as extreme as during winter, but kind of starting extreme conditions. So we had a lot of katabatic winds in the Terra Nova Bay in the Ross Sea, which reached 51 knots. And so that was kind of very, very strong, like continuous for 3 days, basically. And then on the way back, we went through a storm and we really roller coastered very much. And it was only marginal, but we crossed that storm. It was like 61 knots. So we definitely enjoyed our roller coaster park moments. We encountered very cold temperature, but not too much, but like as in line with the season, let's say. But with the wind chill, we just experienced like minus 37 degrees. So it was kind of cold. Personally, it was for me the first time. And when I was taking picture or shooting movie, I definitely experienced it on my skin. So I was, well, I mean, it's a full experience, of course. Laura, you can. So we started to navigate. We started definitely to test our instrumentation actually after we crossed the New Zealand water zone. So we started to definitely take a few measurements, and the first measurements were oceanic profile with XBT probes, okay, that we dropped into the oceans. And also we started to filter water to collect organisms for the biologists. Okay, so this is a first movie that we shoot, just that shows you how this happens, how you drop an XBT probe into the ocean to measure everything. So this is within the ship. So we were on the external deck. Then you have to connect, of course, the probe to the computer, so they can measure. So the expandable bathythermograph, it's a probe that has a very, very thin copper wire that is connected to the computer. So it is dropped to the oceans. When it reaches a certain depth, the signal stops, because each probe is made for a certain depth and doesn't go beyond. And until it reaches this depth, the wire copper just transmits some electric signal that is translated into temperature. And so we drop that regularly into the ocean. So from the high school, we had many questions about how is the pollution in the oceans and in the Southern Ocean. And then our oceanographer on board definitely realized that we were dropping a lot of probes into the ocean as well. So, I mean, it has been a bit a moment of awareness, like, oh my God, we are contributing to the ocean pollution, which is true. I mean, unfortunately, so we will study new methods to not make any more pollution into the ocean. So we proceed our way, and we cross the polar cycle on 23rd of February, and we reach close to the Antarctic coastline on the 25th of February. And there we meet our first pack, actually, drifting pack, and we shoot a short movie just to show people how it is to cross the sea ice. So we can't hear the sound actually. Well, okay, so when we were going across the sea ice, actually, I filmed in my cabin the vibrations actually that I could feel because I was on the side of the ship, so I could definitely felt all the collisions with all the sea ice block, and so I could definitely hear big sounds each time we were colliding with a block, and a lot of vibrations. So we shared that with the high school that was following us, but. So that was the state of the pack when we arrived close to the Antarctic coastline. So of course during summer it's all fractured, it's all fragmented like that by the storms, by the tides, etc. Then when we arrived definitely into the Ross Sea, we had a first stop in Edisto Bay because we wanted to release an oceanographic mooring, which was not part of our scientific program, but we stopped there to release it. And then we proceed our way to Terra Nova Bay, where we had the first geophysic measurements and sediment coring. But this is also where we experienced the more extreme temperature conditions and wind conditions. So this gives a bit of trouble to our oceanographers because most of the launches for the oceanic probe are from the outside, not from the inside. And so when we arrived there in Terra Nova Bay, we definitely saw that there was a bit of problem with the pipe for the launch of the XPT. So it was completely covered by thick frozen ice. I mean, so one of our colleagues tried to really fix the problem, and he was not aware I was filming from the top, so it has not been planned. I'm actually so he used really this broomstick to to detach the ice, but was unable to do that. So we definitely renounced to use the pipe because you can launch the probe without the pipe. Actually, the pipe is useful if you don't want to the copper wire to touch the ship and causes some interferences in the electric signal that is sent to the computer. But you can definitely launch the XPT probe as our colleague is doing right now. Yeah. So that was my spot for the entire cruise mainly. When I was not in the ship, I was there filming the oceanographers having troubles launching the probe actually. So that's what we did. And then because the meteo was so extreme and we were already at the end of the Easter season, we testified the beginning of the sea ice formation during the whole cruise, actually, not only in Terra Nova Bay, but especially in Terra Nova Bay. So I think we were, I mean, for me, it was the first time I experienced that. So of course, the seawater freezes only at minus 1.8 degrees. And usually there are 3 to 4 steps in the sea ice formations, and we were very lucky that we definitely observed them all during the campaign, actually. The first step is when you have some small sea ice crystals that forms at the surface of the ocean when the ocean reaches the freezing point. And so it gives this kind of very smooth surface, like patchy surface, but at some point the entire ocean become covered with this small, very small sea ice crystal. So it's like having a small veil at the very thin veil at the surface. And of course, because of that, the wind doesn't have a lot of influence on the surface of the ocean. So the fetch is very much reduced because of that. So you can see that the viscosity of the wave, it's all completely different. And then because of under the action of the waves, actually those ice crystals agglomerate in pancakes shapes. And little by little, they just grow. And they reach a kind of big size actually. So it gives this kind of very surreal landscape with some kind of like icebergs floating in the sea ice. So it's very particular. It was very beautiful. And once the pancakes reaches important size, I mean, they are stable enough so they can accumulate the snowfall from above. And this is where the sea ice start to thicken. And then they agglomerate between each others, and this forms the new sea ice, actually, the new seasonal sea ice. So we definitely saw everything during that campaign, and that was very beautiful. I mean, it was definitely interesting, but it was also very, very beautiful. Then it just expands during the winter and just crack and melt during the summer, almost everywhere in Antarctica, except in few places where it's almost perennial. So yeah, that was very, very beautiful, actually. Then once we left, we finished our measurements in Terranova Bay, we moved to another location in the Ross Sea. You can move, Laura, I think. And then we finished in this area and decided to move on Laura's area, which was outside. But as you can see, I mean, on this picture is showing you what was the state of the sea ice cover at the moment we decided to leave the Ross Sea, actually. And the sea ice shows, I mean, this figure shows you the sea ice concentration. So in red, it's 100% concentration, and in magenta is about 5 to 10% concentration. But 100% concentration just tells you that in an area of here, the satellite resolution is 3 kilometers by 3 kilometers. Everything is covered by sea ice, but it doesn't tell you if the sea ice is a continuous block, okay, continuous layer, or if it's fragmented. So you have to go through to understand what is the state of sea ice and if you can make some measurements. So actually, Laura's project was located so on the where she's pointing with the mouse right now. So it was fully covered with sea ice, but we didn't know what was the state of the sea ice. So we decided anyway to transit there, and we had to cut through the sea ice to gain a bit of time on the transit. And well, I shot a few pictures there, a few movies, because it was very, very nice, actually. So it was mostly in the dark, and so that was from my cabin. But then after we filmed outside. Laura, puoi non mutarti, perché io penso che Cioè io penso che non sentiamo il suono dei video perché tu ti sei mutata, ecco.
Non ero mutata prima, adesso ho mutato. Forse non sentite il suono perché non è settato per sentire il suono.
Ma forse bisogna metterlo. C'è lì sulla barra del film? No, sulla barra del film in basso.
Sì, qua.
A destra c'è il simboletto del suono.
No.
Boh, lascia perdere, andiamo avanti. Because that was a big iceberg that we saw in the dark at some point, and the crew was a bit scared of it, so they were illuminating it in the dark. So we had a lot of moments like that. So it was quite suggestive. Actually, it was very nice, but not for the crew, actually. So we were going through very, very slowly, 2 knots at maximum or something like that. So yeah. It was not all the nights like that, but when we started to work in Laura's area, then definitely it was a bit like that sometime.
Okay, so we reach our area of study, which is the Cook and Nimitz Glacier continental margin, and the motivation for actually submitting a project for a new survey here was that we wanted to know if there is any evidence of marine-based ice sheet retreat from depth margin in the past. And how is the situation today? Does the ocean circulation influence the stability of the Cook and Nimis Glacier today and also in the past by recovering some geological records and check what happened during the quaternary cycles. So that was the motivation. And also the fact that this area is almost completely unknown. There are some seismic profiles collected by the US. The white tracks here show the location of the existing Multichannel seismic data. And there are some seismic data also from Russian. German Lychenkov collected in at least two different cruises in the past. Some French data, but not sediment core and not bathymetric data. And this is why the bathymetry looks a bit weird with this giant glacial trough here and very rough comparing to the more detailed bathymetry on that side. For example, the western sector here has been swamped several times by different cruises in the past, but this area, because of the sea ice coverage, which is a multi-year sea ice, it's very difficult to be surveyed, and that's why it's so simple. It's so difficult to understand how it looks like really. The Cook and the Nimis are big glaciers comparing to the Mertz and the Astrolabe, which are much smaller glaciers, but they all drained the ice sheet which is covering the Wilkes Basin, the ice sheet which is covering the Wilkes Basin, which is a marine-based ice sheet, this sector here. And so it is supposed to be quite vulnerable to, atmosphere and ocean warming. And that's why we think that understanding what's the stability of these glaciers is quite important for our future, for, predicting model. So as Flo said, we attempt to reach this place and we check if we could actually enter into the sea ice. That's the track of the vessel. And we were approaching the sea ice and we went through the sea ice. But we finally we decided to go out and not even try to go southward because the sea ice was even thicker and so it was quite dangerous for us to attempt to go inside this reddish orange very thick sea ice. So this was the try that we did on March the 6th. And then we decided to leave the area and stay in the continental slope. So the survey then, instead of being on the shelf, was completely confined on the continental slope for the rest of the time. This is a movie that shows our attempt into the sea ice. So that was our primary area where we wanted to go. And then when we arrived there, we did find this sea ice concentration. So we decided to stay in the continental slope. Also because the quality of the data that we were collecting were not very good. Because if you acquire acoustic data, you cannot stay in a noisy place where you do have lots of noise from the breaking the ice, and so it was still possible to perhaps stop and take some oceanographic measurements, but not really bathymetric or even seismic. It was impossible to collect because the ship is changing also the speed, and because the blocks are thick or thin, and so it's difficult to stay on a track and also to maintain a constant velocity. this is the situation that we found when we tried to go through the sea ice on March 6th. So we moved to Plane B, to the sea ice free area in the vicinity, in the continental slope. And we collected some topaz, subbottom topaz, nice geophysical profiles with quite good penetration. This is these two markers are 25 millisecond. The vertical scale is 25 millisecond each tick. So we got a penetration of up to 50 millisecond below the seafloor. And we did see laminations, and that was good because we used that for coring them to find the best place where we could actually penetrate below the seabed up to 7-8 meters with gravity coring. And so we did some gravity sediment cores. We took 2 sediment cores from this mount here to the west of the large glacial valley, which was carved by the Cook and the Nimis. So our hope was to find some distal sediment that was transported and delivered to the ocean and accumulated on this mound just to the west of the main glacial system. We collected a very nice compilation of multi-beam data, which is showing nicely several systems cutting the continental slope, so huge canyon and mounds, but also large slide scarps, which is affecting the sediment slope. We also went to the continental shelf edge, trying to get into the outer shelf at least, to do some oceanographic measurement. That was an attempt that we did on March 9, between 8 and 9, where we also did launch an Argo float, and we left that Argo float there, which is now under the sea ice and is measuring the physical oceanographic properties. That's a video showing when we launch one of them. The Argo floats are left and they are basically passively transported by the ocean currents. And so they measure twice a day. They go up and down across the water column, and they do measurement of temperature and salinity, and also the circulation, the ocean current direction and strength. And if they cannot transmit their measurement to the satellite because of the sea ice, they feed the sea ice, and so they go down again. So they go up and down twice a day for the entire year. And after the winter season, when the sea ice break on that, then the Argo floats start to transmit again to the satellite all the measurement that was recorded during the year. We did launch 2 of them near the continental shelf edge. So we hope to find them in the surrounding in the next year and collect all the measurement that the 2 Argo floats got in this month. That's the point. The idea was to have a measurement across the continental margin of ocean warming, of ocean water which is entering, and also the water which is forming on the continental shelf in the Polinia and is spilling out to the ocean, mixing with the ocean current And also the two buoys which are here will perhaps help us to understand much better how is the circulation across the continental slope, which is westward flowing, but also eastward flowing. So it depends where the two buoys are. We will get a better measurement of these two currents, which are opposite in this small area here. And will help us then for understanding, interpreting the geological and paleoceanographic records from the gravity cores. We collected a transect of gravity cores across this area here. We collected at least 6 gravity cores, and this is a movie showing our operation on board. That's a winch that we use to deploy the gravity core. That's the EK80, which is a subatom, high frequency subatom we use for monitoring during the time, the going down of the core, the coring system, check when it's hitting the floor, and then how is it coming up in time. So the axis, the axis is time. So this is the beginning of the coring going down, and that's hitting the floor, and that's the beginning of coring up. Depending on the color, we can also estimate if the coring is going down vertically or is if there is a kind of drifting of the system. Then the core is taking up and lay down on this system, which is helping to retrieve. We used 4 meters long for the first 2 cores, but then since the core was completely full of sediment, we doubled the core, so we used 8 meters long sediment coring. And we also got a full, up to 7.6 meters of sediments. Then the plastic liner, which is inside the coring system, is put it out and cut in sections of 1 meters and labeled and stored in the fridge. Okay, so the cores that we collected, as I said, are along the transect over here in front of the Mertz and Nimis. And 2 cores are on this mound to the west of the Cook Glacier here. And the philosophy is to have an idea about different provenance, different processes, different downslope and along-slope current strength and shift in the track, in the pathways. So, for example, in this case, core C3 is located here, and it's just to the west, to the eastern levee of this big canyon here, which is this one, right in front of the Nimis trough. So the idea is to have a to collect the geological record on both levees of the different canyons, and to check if there is any switch into this advance and retreat of the coastal glacier. And the idea is also to compare the geological record with the pre-existing one, which is from IODP Expedition 318 from 2010, Carlotta Scuzia and Luis leg, and also the previous sediment cores that we collected from this place here and published in several papers. We do have similar phases in our area with laminated phases and more massive phases when bioturbated. We hope to find more cycles, like in the case of the Mertz continental slope. We have a similar situation, but but recording the Cook Glacier past dynamics. Finally, we also collected some water samples that we filtered, and that was for, this is of interest also of Vincent too, because the idea was to collect water samples and samples at the interface between water and seabed to validate our paleoproxy with present day environmental condition. And this was the operation that we did on board using pump. So this is just a short video showing what we did in the wet lab. So we borrowed from M11 there this instrument. This is our pump, which is pumping water from this so we pump water from 4 meters below the vessel, seawater. That's the position where we have this sink. And then we filter it. Esther Polizza from University of Trieste, she was with us on board, and she did the job for 100 different stations. And then this filter will be checked for diatoms, silicoflagellate, and microorganism content. Plate. So that's the overall view. So the red dots are the water samples that we took. The yellow dot are the sediment cores, the gravity cores. The black dots are the XPT that we shoot, particularly in this place and across the continental shelf. And we also did some seismic. We collected seismic profiles in this area here. We have a small grid. We collected seismic for 1 day and a half only. And this is a video showing how we collected seismic. This was March 17 and 18, and it was incredibly calm and warm. And that was a perfect condition for collecting seismic, because seismic is a quite delicate operation, because we have to deploy guns and a very long streamer, which is 1,500 meters long on the back of the ship. And we really need calm and good weather, calm sea and good weather, no sea ice at all. And that was the condition on March 18 and 17. So we finally decided to do this. Those are the balloons that we use to actually check where the guns are and if they are online. This is the dry lab where we do control how the data we are collecting are coming out. That's the icon. It's going fast. Okay, that's the last slide. Basically, we came back to Christchurch on March 24, and that was the end of our trip. Very long trip, but very successful. Although we had some challenging in the sea ice, we collected very nice data, and We thank all of the crew and the captain of the bus, of course, Franco Sedmak, all the technicians from OGS. We thank PNRA who founded the cruise, and also Otago University, who where is a partner, because Jackson Bigley embarked with us for doing seismic. Also NIWA and COPRI borrowed some, gave us some of the XPT that we used during our cruise. And of course, we also thank Carola, who was the mammal observer on board, and she was crucial, especially for the seismic operation and for the mammal sightseeing. So I think I stop here. We are 10 minutes late. So I don't know if you have questions, or maybe Flo wants to add something.
Thank you. I think Flo's had to leave already.
Yes, she left.
Yeah, so sorry about that. Yeah, thank you. That was really good, and it's really nice to kind of see some of those videos, actually, because I'm a field-based Antarctic researcher. I don't ever get to see any of that kind of yeah, the actually being on the ship and seeing the sea ice. So yeah, that was really good. Thank you. Is there anybody who has any questions, comments, or wants to say anything? Just there's only a small group of us, so just either speak up, I think, actually. Yeah, go ahead.
Okay. Hello. Hi, Laura. I hope you can hear me.
Yes, I do.
Yeah, I just wonder if there anybody from your group working on the existing seismic data, because I do, since we had our last meeting, I think like a year ago. So I'm kind of working on those existing seismic data. I have some result also ready, and slowly start to write any. I think I probably could have a draft like in July. I think it would be very important to check with you, like avoid overlapping. And I also wondering like how many kilometers seismic data you collected?
230. There are not many.
Mm-hmm.
It's just 1 day and a half, so it's a very small grid over that mound. So.
Yeah, I see the location so close to the mound of the seismic, but not exactly on the mound.
Because there was sea ice, so we couldn't go there.
Okay, yeah, that's very pity, because there are also no existing seismic actually cover the mound. Yeah.
I know, the idea was to map the mound, but unfortunately the sea ice was really bad by the time we get there, and that was the only way. I mean, we did survey part of the mound, the distal part, and there are a couple of seismic profiles also in the proximal part, but I agree, I really wanted to go as much as I could closer to the shelf and have a better survey, but unfortunately that was it. That was what we could do.
But I see you got like 2 calls very close to that mound. It's probably very helpful to tell, you know, the age of the sediment, because that area is really like a black hole.
I know. Yeah, we were able to collect the cores, because the core is less difficult than the multi-channel seismic. You know, for running multi-channel seismic, you need at least 2 days, even more perhaps, but at least 2 days of good window, good weather window, and no sea ice, and you know, and it wasn't that at that time. So the only way was to collect 2 sediment cores. That was it. And then when we got good weather, we could go back and do some seismic. But by that time, the sea ice was covering the proximal part, and so we stay in the distal part.
Yeah, that's a pity, but still, I think a lots of nice calls seems. And are there anybody from your group already working on processing the seismic?
We can talk when you can about this.
Okay. Thank you.
Brilliant, thank you. Is there anyone else who has anything they kind of want to add? I know a few people said they haven't actually got a microphone, so. No. Okay, if there's not any other questions, and if Laura's happy, if there's nothing else we kind of want to add to that, I'll stop the recording.
Yeah.